Suppose you have a random sample from a Poisson distribution with parameter lambda. So the sample is y1 through yn. They're independent, identically distributed. We want to show that the sum of the yi's is sufficient for lambda. We want to show it's a sufficient statistic. We're going to do this using the factorization theorem. Now, this is a discrete probability distribution because it's Poisson. The probability that yi is specifically that value little yi is lambda to the yi e to the minus lambda over yi factorial. Since they're independent, the probability of all of those having those values is simply the product of all these. So we have lambda to the y1 times lambda to the y2, etc., e to the minus lambda repeated n times, and we have y1 factorial, y2 factorial, etc., which we can then rewrite as lambda to the sum of yi, e to the minus n lambda, times 1 over the product of all the yi factorials. The factorization theorem says that if you can split it into two functions, and one of them has all of the lambdas, and only has y's in the form of the statistic, then the statistic is sufficient. And that's what we have here. This first piece, with these two factors, has all of the lambdas. There's no lambdas over here. And the only y's that show up in this piece show up in the sum of yi. Therefore, the sum of yi is a sufficient statistic for the parameter lambda. Notice it doesn't matter that there are other factors of y here. What matters is the factor that has the lambdas in it, and that there are no other y's besides the sufficient statistic.